One of the hottest debates in recent years, no pun intended, revolves around climate change. Brock Earth Sciences professor Uwe Brand has discovered a way to accurately measure atmospheric oxygen levels at any given geologic time. Dr. Brand, how might this help to finally convince doubters that climate change actually is real?
Well, as a scientist, we're always trying to find better ways, more improved ways to show the evidence that points us in the right direction, such as climate change or global warming. And we probably, none of us will live long enough to really experience, 5-degree change, because that probably would convince everybody. Unfortunately, our lifespan is not that long. That's why we resort to geological materials, which of course, have a tremendous lifespan or rock span. And we can only hope that with better evidence, with better results and so on, we can convince even a few people. And it's not so much convincing them, but at least getting them to acknowledge that we need to do something. Even if you don't believe in it, doing something about climate change and air pollution and so on is still always a good thing to do.
Dr. Brand, can you explain the process that you developed?
Well, what we do is we clean it first, and we look at these inclusions or look for these trails of them under the microscope. And then we use this material and put it into a mass spectrometer, which is a fancy machine that can look at things in very small, in very minute detail, and measure it in the small amounts in detail. And so what we do is we put the sample in there, which is a tiny sample, and we crush it. And during this crushing process, some of that gas escapes. And as it escapes and makes its way into the machine, we actually start measuring how much oxygen is there, how much CO2, carbon dioxide is there, how much nitrogen. So we can precisely measure. Through the measurement, we have to develop the machine, use known amounts that we put into the machine. And so we have to be confident ourselves that the results we get are real numbers, not just something that the machine has manufactured.
Now, the next step is that your process gets, sent out to other scientists around the world to actually use your process. When does that begin?
Well, you talked about convincing people that climate is real. We have the same problem in convincing people that our measurements are real. And this is other scientists who have used models where they look at isotopes or elements, and then they try to say, well, under certain conditions, we're going to find X amount, other conditions, Y amount. And then based on these extrapolations and modeling of trends, we can say, well, 1 billion years ago, the atmosphere was maybe 1% oxygen. So we don't have to do this anymore. We just have to find halite that is that old. And we have found halite that is about, the oldest we have is 2 billion years old. And we can analyze all of these. You may have to analyze 10 samples to get one good one. So not everyone will give you a good result, but you just keep analyzing more and more. And then eventually you're going to get a nice target with a very small range of results. And so you can be confident that, let's say, 800 million years ago, the atmosphere was about 11% instead of the 21, which it is today. And this should help us also in defining of how life evolved on our planet. Remember, the other big thing besides climate change is, of course, finding life on Mars and other planets and so on. And we don't have to go that far. We're still trying to tackle of how life actually evolved on this planet. Was it the oxygen that was driving the evolution of life, or was it the other way around? Was it the organisms driving the evolution of oxygen? And I believe with our method and being able to actually measure the amounts, we don't have to rely on modeling. We can say, at this point in time, the organisms were already here. The oxygen level was already quite high. Therefore, they did not have to wait for the oxygen to be made. It was already there. So life, the way we see it, probably came afterwards. So the geological community is really split into two groups, as you can imagine. You know, one believes that it was the oxygen that was the driver. The other one thinks that it was the organism that was the driver.
Fascinating, fascinating. Dr. Brand, thank you so much for joining us today.
No problem. My pleasure.